Hello students, today we will going to discuss a very important and interesting topic from your plus 1 chemistry book, chapter Some Basic Concepts of Chemistry. The topic is Empirical Formula and Molecular Formula. First of all, let's discuss what is percentage composition or mass percentage composition, which will be very helpful for calculating the empirical and molecular formula numerical problems. So it gives the mass of each element expressed as the percentage of the total mass. So mass percentage of an element is equal to number of parts by mass of an element divided by the molar mass of that compound multiplied by 100. Let's understand this concept by doing a numerical problem. Calculate the mass percentage composition of glucose. So the molecular formula of glucose is C6H12O6. So from here we can calculate the molecular mass of glucose, which comes out to be 6 into 12 plus 12 into 1 plus 6 into 16, it is equal to 180. So in first case, the mass of carbon in glucose molecule is 6 into 12 because there are 6 carbon atoms in glucose molecule and each carbon atom has atomic mass 12 AMU. So it becomes 72. So the mass percentage of carbon is 72 divided by the total mass of the glucose molecule 180 into 100, it is equal to 40%. Similarly, mass of hydrogen in glucose molecule is 12 into 1, that is equal to 12 gram. So the mass percentage of hydrogen becomes 12 divided by 180 into 100, that comes out to be 6.67%. Same as that, mass of oxygen in glucose molecule is 6 into 16, that comes out to be 96. So the mass percentage of oxygen is equal to 96 divided by 180 multiplied by 100, that comes out to be 53.33%. So that's all with percentage composition. So try one numerical which I have given to you, that is calculate the mass percentage of composition of urea, and the molecular formula of urea is NH2CONH2. Now let's understand what is empirical formula. The formula which gives the simple whole number ratio of the atoms of various elements present in one molecule of the compound is called empirical formula. For example, the empirical formula of hydrogen peroxide is HO. As we know, the actual formula of hydrogen peroxide is H2O2. So in hydrogen peroxide molecule, 2 hydrogen atoms and 2 oxygen atoms are there. So the ratio becomes 2:2. That is, the simple ratio between hydrogen and oxygen is 1:1. That is, the empirical formula of hydrogen peroxide is HO. So similarly, empirical formula of benzene is CH. That is, carbon and hydrogen are present in ratio 1:1 because same as that of hydrogen peroxide, the formula of benzene is C6H6, in which carbon and hydrogen are in ratio 6:6 and the simple whole number ratio is 1:1. Let's take another example, that is empirical formula of glucose is CH2O, that is carbon, hydrogen and oxygen are present in ratio 1:2:1. This is because the actual molecular formula of glucose is C6H12O6. So the actual ratio of carbon, hydrogen and oxygen is 6:12:6 and the simple ratio is 1:2:1. So that is how the empirical formula of glucose comes out to be CH2O. So next is, what is molecular formula? The formula which gives the actual number of atoms of various elements present in one molecule of the compound is called molecular formula. That means the molecular formula represents the actual number of atoms present in one molecule of that compound. For example, the molecular formula of hydrogen peroxide is H2O2. Molecular formula of benzene is C6H6. This is the actual formula of benzene. And molecular formula of glucose is C6H12O6. So the molecular formula is equal to small n into empirical formula, where n is the simple whole number values 1, 2, 3 and so on. It is equal to the ratio of molecular mass and the empirical formula mass. For example, n in benzene is 78, that is the molecular mass of benzene, divided by empirical formula mass, that is 13, which comes out to be 6. Therefore, the molecular formula of benzene is 6 multiplied by empirical formula, which is CH. That comes out to be C6H6. So students, always remember one important formula, that is molar mass is equal to 2 into vapor density, which is useful in calculating the numerical problems of empirical formula and molecular formula in some cases. Let's understand the concept of empirical formula and molecular formula by doing some numerical problems. So first is, a compound contains 4.07% hydrogen, 24.27% carbon and 71.65% chlorine. Its molecular mass is 98.96. What are its empirical and molecular formulas? So in this numerical, first we have to find out the empirical formula. So to find out empirical formula, first we have to write the elements which we have given in the numerical statement. So here in this numerical, the elements are carbon, hydrogen and chlorine. Then we have to write the percentage of that elements. So the percentage of carbon is 24.27, hydrogen is 4.07 and chlorine is 71.65%. Then we have to write the atomic masses of that elements present in the numerical. So first, the atomic mass of carbon is 12, of hydrogen is 1 and of chlorine is 35.5. So our next step is to find out the moles of atoms of each element. So to find out moles of atoms, we divide the percentage of each element by its atomic mass. This gives the moles of atoms of various elements in the molecule. So in first case, the moles of atoms of carbon is equal to 24.27 divided by 12. That comes out to be 2.02. In case of hydrogen, 4.07 divided by 1. That comes out to be 4.07. And in case of chlorine, 71.65 divided by 35.5. It comes out to be 2.02. So our next step is to find out the mole ratio or atomic ratio of every element in that compound. So to find out this, divide the result obtained in the previous step by the smallest value among them to get the simplest ratio of various atoms. So in the previous results, we have the smallest value, that is 2.02. So we have to divide each value by 2.02. So in case of carbon, 2.02 divided by 2.02, it comes out to be 1. In case of hydrogen, 4.07 divided by 2.02, it is equal to 2. And in case of chlorine also, it comes out to be 1. So in the last step, we have to find out the simple whole number ratio of each element in the molecule of that compound. So in this case, it comes out to be 1 of carbon, 2 for hydrogen, and 1 for chlorine. The empirical formula of the compound comes out to be CH2Cl. So our next step is to calculate the molecular formula of the compound. So to find out the molecular formula, we calculate the empirical formula mass by adding the atomic masses of the atoms in the empirical formula. So in this empirical formula, mass is 12 for carbon plus 2 into 1 for hydrogen plus 35.5 for chlorine, that comes out to be 49.5. So here in this numerical problem, molecular mass is given, which is 98.96. So from this we have to find out the value of N, that is the ratio of molecular mass and the empirical formula mass, which is equal to 98.96 divided by 49.5, that comes out to be 2. So the molecular formula of the compound is 2 into empirical formula, which comes out to be C2H4Cl2. That is the required answer. Let's see another numerical problem. A compound contains 40.68% carbon, 5.08% hydrogen, and the rest is oxygen. The vapor density of compound is 59. What is the molecular formula of the compound? So in this step also, first we have to find out the empirical formula. So first of all, write down the elements which are given in the numerical problem. So in this numerical, we have given carbon, hydrogen, and oxygen. So next we have to write the percentage of each element. So the percentage of carbon is 40.68, hydrogen is 5.08, and the percentage of oxygen is 100 minus the sum of the percentages of carbon and hydrogen, that is 45.76, which comes out to be 54.24. The sum of all the percentages should be 100. So our next step is to write the atomic masses of each element. So atomic mass of carbon is 12, hydrogen is 1, and oxygen is 16. So in next step, we have to find out moles of atoms, which we can calculate by dividing the percentage of each element by their atomic masses. So in case of carbon, it is 40.68 divided by 12. It comes out to be 3.39. In case of hydrogen, it is 5.08 divided by 1. That is equal to 5.08. And in case of oxygen, it is 54.24 divided by 16. It comes out to be 3.39. So our next step is to find the atomic ratio, mole ratio. So to find out this, we divide the results obtained in the previous step by the value which is the smallest among them. So in that case, the smallest value is 3.39. So we divide all the values by 3.39. So first, in case of carbon, 3.39 divided by 3.39, it comes out to be 1. And in case of hydrogen, 5.08 divided by 3.39, it is equal to 1.5. And in oxygen, it is 3.39 divided by 3.39, it comes out to be 1. Now let's make the values obtained in the previous step to the nearest whole numbers. And for this, multiply the values by a suitable integer so that the values become whole numbers. So in this case, we have to multiply the values by 2 so that the simple ratio of carbon is 2 and of hydrogen is 1.5 multiplied by 2, it is equal to 3, and for oxygen is also 2. So the empirical formula of the compound is C2H3O2. So our next step is to calculate the molecular formula. So for that, first we have to find out the empirical formula mass, which we can calculate by adding the atomic masses of all the elements present in the empirical formula. That comes out to be 59. So in the numerical statement, the vapor density is given, and as we know, the molecular mass of a compound is equal to 2 into vapor density. So here the molecular mass is equal to 2 into 59, that is 118. Now we can easily calculate the value of small n, which is the ratio of molecular mass and the empirical formula mass, that is equal to 118 divided by 59, and the value of n comes out to be 2. So the molecular formula of the compound is 2 multiplied by empirical formula, and the answer is C4H6O4. Let's see another numerical problem which is somewhat different from the first two numericals. 4 gram of copper chloride on analysis was found to contain 1.890 gram of copper and 2.110 gram of chlorine. What is the empirical formula of copper chloride? So in this numerical, the mass percentage of any element is not given to us. So in first step, we have to calculate the mass percentage of different elements in the numerical, which we can easily calculate by applying the formula, that is mass percentage of copper in copper chloride is equal to weight of copper divided by total weight of copper chloride multiplied by 100, that is equal to 1.890, which is the weight of copper, divided by 4 gram, which is the total weight of copper chloride, multiplied by 100, that comes out to be 47.3%. Similarly, the percentage of chlorine in copper chloride is equal to weight of chlorine divided by total weight of copper chloride multiplied by 100, that is equal to 2.110 divided by 4 into 100, that comes out to be 52.7%. So in the second step, we have to calculate the empirical formula. So first we have to write the elements present in the numerical problem, that is copper and chlorine. So then the percentage of copper 47.3 and of chlorine is 52.7%. Then we can write the atomic masses of copper, that is 63.5, and of chlorine is 35.5. So our next step is to find out the moles of atoms, which we can easily find out by dividing the percentage by atomic mass of each element. So in case of copper, it comes out to be 47.3 divided by 63.5, it is equal to 0.74, and in case of chlorine, 52.7 divided by 35.5, it is equal to 1.48. So in the next step, we have to find out the mole ratio or atomic ratio. So the smallest value among the previous obtained values is 0.74. So we can divide both the values by 0.74. So in case of copper, 0.74 divided by 0.74, it comes out to be 1. And in case of chlorine, 1.48 divided by 0.74, it comes out to be 2. So our last step is simple whole number ratio of both the elements. We can write as copper is 1 and for chlorine is 2. So the required empirical formula of the compound is CuCl2. So here are some numerical problems which you have to calculate by yourself. Note it down in your notebook and try to solve all the three numericals by your own. If you like my video, please share it with your friends and other students of +1 and +2. Please subscribe my channel and click the bell icon for further updates. Thanks for watching.